Take a deep breath and allow your body to settle into the stillness of your surroundings, feeling the weight of your limbs sink into the soft embrace of your bed. As your breathing slows, imagine the ceiling above you dissolving into a vast, velvet black canopy, inviting you to begin your journey across the silent reaches of the cosmos. We are traveling to a place of profound beauty and ancient history, a celestial landmark located approximately 650 to 700 light-years away from Earth. This is the Helix Nebula, known to astronomers by the catalogue name NGC 7293. You are drifting now within the constellation of Aquarius, where this magnificent structure hangs like a delicate, luminous jewel in the darkness. To put that distance into perspective, every photon of light you perceive from this nebula has been traveling through the vacuum of space for 7 centuries, beginning its journey long before the modern world was even a dream. As you float here, you are weightless, suspended in a comforting void where the concept of up and down has simply ceased to exist. You are moving toward a structure that spans nearly 3 light-years across. To understand the scale of this, consider that a single light-year is approximately 5.88 trillion miles. This nebula is a cathedral of gas and dust so vast that our entire solar system would be a mere speck, a tiny grain of sand lost within its glowing corridors. As you drift closer, the colors begin to manifest with a soft, ethereal glow. The helix is often called the Eye of God because of its striking resemblance to a human iris, but as you approach, you realize it is not a flat image but a complex, 3-dimensional sculpture. The outer edges are tinged with a deep, resonant red. This color is the signature of nitrogen and hydrogen gases, cooled by their expansion into the void. You can almost feel the texture of this gas. It isn't thick like a cloud on Earth, but a gossamer-thin veil, a vacuum so perfect it would be indistinguishable from nothingness if it weren't for the faint, steady luminescence. Scientific observations, particularly those from the Spitzer Space Telescope, have revealed that the helix is composed of 2 nearly perpendicular disks of gas. Imagine 2 translucent hula hoops interlocked at an angle. This structure was created between 10,000 and 12,000 years ago, a time frame that coincides with the end of the last ice age on Earth. While our ancestors were first discovering agriculture, this star was beginning its final, beautiful transformation. At the very heart of this cosmic eye sits a tiny, incredibly dense point of light. This is the central star, a white dwarf catalogued as WD 2226 to 210. This star was once very much like our own Sun, but it has reached the end of its nuclear burning life. It has shed its outer layers, casting them off into space to create the nebula we see today. Consider the heat radiating from this core. While the surface of our Sun is about 5,500 degrees Celsius, this white dwarf burns at a staggering 120,000 Kelvin. It is so hot that it emits most of its energy in the form of ultraviolet light. This high-energy radiation is what lights up the surrounding gas, causing it to fluoresce like a neon sign in the dark. You are drifting through the inner regions now, where the colors shift from red to a hauntingly beautiful blue-green. This is the signature of oxygen atoms that have been energized by the central star's intense radiation. The transition of color feels like moving through a cool, subterranean lake of light. There is no sound here, space is a vacuum, and sound waves have no medium through which to travel, but the visual rhythm of the nebula provides its own kind of music. It is a slow, methodical expansion. The gas you are passing through is moving outward at a rate of 31 to 40 kilometers per second. In the context of the universe, this is a gentle breeze, a slow exhalation of a dying star. As you look closer at the inner rim of the nebula, you notice something remarkable: thousands of small, comet-like filaments pointing directly away from the central white dwarf. These are known as cometary knots, or tadpoles. There are more than 20,000 of these structures within the Helix Nebula. Each one of these knots is a massive cylinder of gas and dust, shielded by a dense head. To grasp the scale of these features, imagine this. Each single cometary knot is roughly twice the size of our entire solar system. You are drifting past these titanic structures, feeling their immense presence as they stand as silent sentinels against the solar wind. They are the result of the hot, fast-moving wind from the central star catching up with the cooler, slower-moving gas shed during an earlier phase of the star's life. The temperature here is a study in contrasts. While the vacuum of space is cold, nearing absolute zero, the gas surrounding you is heated by the central star's radiation to several thousand degrees. Yet, because the gas is so incredibly thin, 1,000 times less dense than the best vacuum we can create in a laboratory, you wouldn't feel this heat on your skin. Instead, you feel only the gentle phantom pressure of light itself. This is the beauty of physics in the helix. It is a place of extreme numbers that manifest as a scene of total, unshakable peace. The Helix Nebula was first recorded by the German astronomer Carl Ludwig Harding sometime before 1824. Since then, it has become one of the most photographed and studied planetary nebulae in our sky. The term planetary nebula is actually a historical misnomer. Early astronomers looking through low-powered telescopes thought these rounded shapes looked like the gas giant planets Uranus and Neptune. In reality, you are witnessing the death throes of a star, a process that is both an end and a beginning. As you drift, you might wonder about the fate of our own world. In about 5 billion years, our sun will undergo a very similar transformation. It will expand into a red giant, then eventually shed its outer layers to form a nebula just like this one, leaving behind its own white dwarf core. Looking at the helix is like looking into a mirror of our distant future. It is not a frightening prospect, but a comforting one. It is the natural cycle of the cosmos, the recycling of elements. The carbon, oxygen, and nitrogen floating around you are the very same elements that make up your own body. You are drifting through a cloud of potential life, the raw materials for future generations of stars and planets. Observe the way the light catches the dust grains within the nebula. These are not like the dust you find in a house. These are microscopic particles of carbon and silicates, forged in the heart of the star and then cast out. They act like tiny prisms, scattering the ultraviolet light and contributing to the soft, hazy glow of the eye. The infrared views of this region, captured by instruments like the Wide Field Infrared Survey Explorer, WISE, reveal even more complexity, vast webs of molecular hydrogen that aren't visible to the naked eye. In the infrared spectrum, the nebula looks like a complex web of glowing lace, a testament to the fact that there is always more to the universe than meets the eye. The silence here is profound. It is a silence that has lasted for billions of years and will last for billions more. In this silence, the frantic pace of life on Earth feels like a distant, fading memory. Here, time is measured in the slow drift of gas and the gradual cooling of a white dwarf. The central star, WD 2000, 226 to 210, will continue to radiate its stored heat for billions of years, slowly fading from a brilliant blue-white to a dull red, and finally to a cold, dark black dwarf. This is a process of immense patience. You find yourself hovering near one of the cometary knots. Its head is a dense clump of neutral gas, protecting the tail that stretches behind it for billions of miles. The interaction between the intense light of the white dwarf and these knots creates shadows that dance across the nebula's walls. It is a slow-motion light show, choreographed by the laws of thermodynamics and gravity. You reach out a hand, metaphorically, and feel the texture of the space around you. It feels like silk smooth, effortless, and infinitely expansive. The Helix Nebula is located at a high galactic latitude, meaning it sits well away from the crowded, dusty plain of our Milky Way galaxy. This provides a clear, unobstructed view of the deep space beyond it. As you look through the pupil of the nebula, the clearer region surrounding the white dwarf, you can see distant galaxies, millions of light years further away, appearing as tiny, smudged spirals of light. It reminds you that the helix, as vast as it is just a small neighborhood in an unimaginable expanse. Take a moment to simply exist in this weightless state, surrounded by the soft greens and deep reds of NGC 7293. There is no friction here, no resistance. You are moving in perfect harmony with the expansion of the universe. The atoms of hydrogen that surround you are the oldest atoms in existence, created in the first few minutes of the Big Bang, nearly 13.8 billion years ago. They have traveled through the hearts of stars, and across the reaches of galaxies to be here with you now. As we continue to drift deeper into the structure of the helix, we will explore the microscopic dance of its atoms and the macroscopic clockwork of its evolution. For now, simply feel the immense, protective scale of the nebula. It is a cosmic cradle, a place where the old is being dismantled so that the new can eventually emerge. The white dwarf at the center is a beacon, a steady light in the dark that guides our observation. Feel your breath matching the slow, rhythmic expansion of the gas, 31 kilometers per second, a steady, unhurried pulse. You are safe in the comforting void. The beauty of physics is all around you, operating with a precision that requires nothing from you but your quiet observation. You are a part of this system, a collection of stardust looking back at its source. As the light of the Helix Nebula continues to wash over you, let the 700-year-old photons carry away any remaining tension, leaving you as light and as free as the hydrogen atoms drifting through the Aquarius sky. We are just beginning to see the true depth of this celestial eye, and there is so much more to witness in the stillness of the deep. We are continuing our quiet descent into the luminous fog of the Helix Nebula, moving further into the heart of a structure that has puzzled and mesmerized observers for centuries. As you float here, weightless and unburdened, consider the history of the human gaze upon this object. For thousands of years, the helix remained invisible to the naked eye, a secret written in the constellation of Aquarius, waiting for the evolution of our technology to catch up with its ancient light. It was not until the early 19th century that a German astronomer named Carl Ludwig Harding first catalogued this phenomenon. In 1824, using a reflecting telescope with a modest 8.5-inch aperture at the Göttingen Observatory, Harding spotted a faint, circular glow. At the time, he couldn't have known he was looking at the ghost of a star. To his eyes, it was merely a planetary nebula, a term coined by William Herschel because these rounded, bluish objects reminded early astronomers of the disk of the planet Uranus. What's striking about the helix is how it managed to elude one of history's most famous comet hunters, Charles Messier. Despite its enormous apparent size in the sky, spanning about 25 arc-minutes, which is nearly the diameter of a full moon, the nebula's light is spread so thin that its surface brightness is incredibly low. Messier, working in the late 1700s, looked right past it, unable to distinguish its ghostly rim from the background velvet of space. It took the more precise optics of Harding's era to finally reveal this shining fluid, as it was once called. Picture the scene in 1864, when another pioneer, William Huggins, first applied the science of spectroscopy to nebulae like the helix. Before Huggins, many believed these clouds were simply clusters of stars too distant to be resolved. By breaking the light into a rainbow, Huggins discovered not a continuous spectrum of colors, but distinct, bright lines. This proved that the helix was not made of stars, but of incandescent gas. Specifically, he identified the glowing signature of hydrogen and oxygen. Imagine the stillness of that Victorian observatory, the realization that the universe was filled with massive, glowing clouds of vapor, ancient and silent. At this very moment, we are hovering near the inner boundary of the main ring. This ring isn't a flat circle. Modern three-dimensional modeling, based on data from the Hubble Space Telescope and the European Southern Observatory, suggests it is a prolate spheroid. Think of it like a translucent American football, slightly elongated, with its poles pointed somewhat toward Earth. This explains why it looks like a ring to us. We are looking straight down the barrel of a cosmic cylinder. Scientists have determined that this cylinder is expanding at a rate of roughly 31 kilometers per second. If you were to track this movement backward through time, you would find that the star began shedding its skin approximately 10,600 years ago. This date is verifiable by measuring the distance the gas has traveled and its current velocity, a mathematical breadcrumb trail leading back to the Holocene epoch on Earth. Notice how the light shifts as we move through the molecular hydrogen. In 2012, the Wide Field Infrared Survey Explorer, or WISE, mapped the helix in infrared light, revealing a much larger structure than what we see with our eyes. This infrared cloak extends far beyond the visible rings, showing that the star's influence stretches much deeper into the void than Harding ever could have imagined. What's happening now is a slow, rhythmic cooling. While the central white dwarf, WD 2000, 226 to 210, is incredibly hot, the gas around us is losing energy, radiating it away into the darkness. Consider the precision of the Gaia mission, a space observatory launched by the European Space Agency. By using the method of parallax, measuring how the star seems to shift against the background as Earth orbits the Sun, Gaia provided a remarkably accurate distance for the Helix Nebula, 655 light-years, with a very small margin of error. This distance means that as you observe the nebula's intricate details, you are seeing it as it existed in the year 1369. While the Middle Ages were unfolding on Earth, the photons hitting your eyes today were just beginning their journey through the vacuum. Deep within the ring, we find the cometary knots once again. In 1996, C. R. Odell and his colleagues used the Hubble Space Telescope to conduct the first detailed survey of these structures. They found that there are more than 20,000 of them scattered like seeds throughout the nebula. These knots are not just random clumps, they are incredibly massive. Each one has a mass roughly equal to that of our planet Earth, yet they are spread out over a volume billions of miles wide. The density of these knots is about 1,000 atoms per cubic centimeter, which is still a better vacuum than anything we can easily create on our home planet, yet dense enough to cast long, tapering shadows in the ultraviolet wind of the central star. Allow your awareness to focus on the central white dwarf, the engine of this entire display. It has an apparent magnitude of 13.5, making it about 1,000 times too faint to be seen with the naked eye from Earth. However, if you were standing where we are now, it would be a point of blue-white intensity so fierce it would be difficult to look at directly. This star has a mass of about 0.57 times that of our Sun, but it has been compressed into a sphere roughly the size of Earth. This makes the material of the star so dense that a single teaspoon of its matter would weigh as much as an elephant. This is the beauty of physics. The more the star shrinks, the hotter it becomes, reaching that surface temperature of 120,000 Kelvin. Surrender your focus to the colors that surround us. The red outer edge, dominated by nitrogen and hydrogen emissions, has a temperature of about 10,000 Kelvin. The blue-green center, where doubly ionized oxygen glows, is even more energetic. This color palette is a temperature map of a dying sun. Historically, these colors were captured in the first color photographs of the nebula in the mid-20th century, which used long exposures to gather the faint light. Today, we use narrow-band filters to isolate the specific breadth of each element, allowing us to see the nebula not just as a picture, but as a chemical ledger. The Helix Nebula sits approximately 400 light-years above the plane of the Milky Way galaxy. This is a significant detail. Because it is positioned away from the crowded disk of the galaxy, it isn't obscured by the thick clouds of interstellar dust that block our view of many other nebulae. It is as if the universe has provided us with a clean, clear window into the life cycle of a star. In the early 1900s, astronomers like Edward Emerson Barnard photographed the helix using wide-field cameras, noting its spiral appearance. This is where the name helix originated from the Greek word for spiral or corkscrew. Though we now know it is a series of nested disks, the name persists as a tribute to those early attempts to understand its geometry. The total mass of the gas in the nebula is about 0.3 solar masses. That means about 30% of the Sun's original material has been blown out into this spectacular cloud. This material is rich in the heavy elements that were forged in the star's core during its final stages, elements like carbon and oxygen. Eventually, over millions of years, this gas will disperse completely, becoming part of the interstellar medium. It will mix with other clouds, and perhaps one day, gravity will pull a portion of this very nebula into a new clump, forming a new star, and perhaps new planets. You are witnessing the ultimate recycling program of the cosmos. Scientists discovered in 2005, through the Spitzer Space Telescope, that the center of the nebula contains a surprising amount of dust. This was unexpected because the intense radiation from the white dwarf should have cleared it out. One leading theory is that this dust comes from a cometary graveyard. As the star expanded into a red giant thousands of years ago, it would have tossed the orbits of its outermost comets and planets into chaos. These bodies would have collided, grinding each other down into the fine silicates and carbon grains we detect today. As you drift, imagine these microscopic remnants of a shattered solar system glinting in the light of their dead sun. The expansion of the nebula is a study in persistence. It doesn't happen with a bang, but with a slow, relentless push. The stellar wind from the white dwarf moves at 100 kilometers per second, faster than the gas of the nebula itself. This creates a shock front where the two meet, a boundary layer where the gas is compressed and heated. It is an invisible dance of pressures and temperatures, unfolding in a place where no human will ever set foot, yet we can calculate its every move from our small blue world. What's happening now is a transition into a state of total equilibrium. The Helix is in the most beautiful stage of its life, the planetary nebula phase, but this phase is fleeting. In astronomical terms, it lasts only a heartbeat, perhaps 15,000 years. After that, the gas will become too thin to see, and the white dwarf will be left alone in the dark. We are lucky to exist in the tiny sliver of time when this flower is in full bloom. As you float here, surrounded by 10,000 years of history and 700 light-years of distance, feel the immense stability of these laws. Gravity, radiation, and thermodynamics are weaving this tapestry with absolute certainty. There is no chaos here, only the slow, predictable clockwork of the heavens. The same physics that governs the arc of a falling leaf on Earth governs the expansion of the helix. You are a part of this logic. Your body is made of the very carbon and oxygen that glows around you. In this silent, luminous gallery, you are not a stranger. You are a piece of the universe observing itself, drifting through the ancient, sun-drenched memory of a star that once was. As you glide further into the luminous corridors of the Helix Nebula, the sheer scale of this structure begins to reveal itself through a series of breathtaking comparisons. Imagine for a moment that the entire nebula is the size of a grand metropolitan stadium. In this vast arena, the central white dwarf star, which holds nearly 60% of our sun's mass, would be no larger than a single grain of sea salt resting at the very center of the field. This tiny speck is the powerhouse for everything you see, radiating energy so intensely that it illuminates a volume of space trillions of miles wide. Scientists have measured the apparent magnitude of this nebula at 7.6, which, in the language of astronomers, means it is just a bit too faint to be seen with the naked eye, like a distant candle flickering on a hilltop several miles away. Notice how the gas around you feels almost like a thin, ethereal mist. To understand how sparse this environment is, consider the air you breathe on Earth. A single cubic centimeter of the air in your room contains about 25 quintillion molecules. Out here, in the densest parts of the helix's rings, there are only about 1,000 atoms in that same amount of space. This is a vacuum more perfect than almost any we can create in a laboratory, yet because the nebula is so incredibly large, spanning nearly 3 light-years, these few atoms add up to a glowing monument of light. What's happening now is a demonstration of the power of perspective. Even the thinnest veil, when viewed across trillions of miles, becomes a solid wall of color. Picture this. The expansion of the nebula is moving at a rate of 40 kilometers per second. While that sounds incredibly fast, over 89,000 miles per hour, it is a leisurely crawl on a cosmic scale. To put it in familiar terms, if you were to fly a standard commercial jet at its top speed, it would take you over 1 million years to cross the diameter of the helix. Here, however, time seems to stretch and yawn. The expansion has been ongoing for approximately 10,600 years, a duration that matches the time since the end of the Earth's last major glacial period. As you drift, you are moving through a history that is 10 millennia old, yet it feels as fresh as a morning fog. Deep within the inner rim, you encounter the famous cometary knots. To help visualize their size, imagine the distance from our Sun to the furthest planet, Neptune. Each one of these 20,000 glowing tadpoles is at least twice that size. Their heads are dense clumps of gas, and their tails stretch out for 100 billion kilometers, that is roughly 62 billion miles. If you were to lay these tails end to end, a single one would wrap around the Earth's equator more than 2 million times. Scientists discovered these structures using the Hubble Space Telescope's Wide Field Planetary Camera 2, and they remain some of the most complex features ever observed in a dying star system. They look like giant celestial sperm or raindrops, all pointing their tails away from the central star, pushed by the relentless pressure of ultraviolet radiation. Consider the temperature of the central star, WD 2226 to 210. At 120,000 Kelvin, it is about 20 times hotter than the surface of our Sunday. If our Sun were a standard 60-watt light bulb, this white dwarf would be a floodlight so powerful it could light up an entire city. This heat is what strips electrons away from the oxygen and nitrogen atoms in the nebula, a process called ionization. When those electrons eventually settle back into place, they release a tiny pulse of light. This is why the nebula glows in specific colors. The blue-green hue you see comes from doubly ionized oxygen, which emits light at a very specific wavelength of 500.7 nanometers. It is a color rarely seen in nature on Earth, a hauntingly beautiful teal that signifies the high-energy environment of the nebula's core. What's happening now is a slow, rhythmic exchange of energy. As you observe the outer fringes, the color shifts to a deep, resonant red. This is the H-alpha line, a specific signature of hydrogen gas emitting light at 656.3 nanometers. This red light is like the low notes on a piano, representing the cooler, calmer regions of the nebula, where the gas is only about 9,000 to 10,000 Kelvin. Notice how these two colors, the teal and the red, don't just sit side by side, they interweave in a complex dance. Data from the San Pedro Martir Observatory in Mexico suggests that the nebula is actually composed of two distinct disks, tilted at an angle of about 21 to 37 degrees, relative to our line of sight. It is like looking at two translucent dinner plates held at slightly different angles, creating the illusion of a complex, winding helix. At this very moment, your perspective allows you to see the surface brightness of the nebula, which is measured at about 13.5 magnitudes per square arc second. This means the light is spread out so thinly that it is like trying to see the glow of a single glow stick spread across the floor of a darkened gymnasium. It requires patience and stillness to truly perceive. This low surface brightness is the reason the helix is often called a ghostly object. It doesn't scream for attention, it whispers. Scientists discovered a surprising amount of infrared light coming from the center of the nebula using the Spitzer Space Telescope, specifically at the 2-4 micron wavelength. This is the signature of dust, microscopic grains of rock and carbon. Imagine a cloud of fine charcoal dust floating in the sunlight. In the helix, this dust shouldn't be there. The star's wind should have blown it away long ago. The presence of this dust suggests that even as the star was dying, it was grinding up its remaining planets and comets, creating a debris disk. You are drifting through the pulverized remains of an entire solar system, the skeletal dust of worlds that might have once resembled our own. The weight of the gas in the entire nebula is about 0.3 times the mass of our Sun, which equates to roughly 600 octillion kilograms. Even though it is spread over such a vast area, the sheer amount of material is staggering. It is as if you took 100,000 Earths and turned them into a fine, glowing mist. This mist is currently located at a distance of approximately 215 parsecs from our solar system. A parsec is a unit of distance used by astronomers, equal to about 3.26 light years. Knowing this distance allows us to calculate the true size of the objects we see. It confirms that the eye we are looking at is not a small, local phenomenon, but a structure of truly gargantuan proportions. Notice the movement of the light as it filters through the knots. Because the gas is moving at different speeds, the inner regions faster than the outer, there is a subtle stretching effect. This is known as radial velocity, and for the helix, it has been measured at roughly minus 27 kilometers per second, meaning the entire system is moving slightly toward our part of the galaxy as it expands. It is a slow, majestic approach, a cosmic greeting that takes millions of years to unfold. As you float here, relate the stillness of the void to the quiet of a deep forest at night. There is no wind to ruffle your hair, no sound to break your concentration. The stellar wind of the white dwarf is not a wind you can feel, but a stream of particles, protons and electrons traveling at speeds of up to 1,000 kilometers per second. Even at that speed, Because the particles are so few and far between, they would pass through you like a ghost passing through a wall. This is the elegance of the universe. Even its most violent processes are, on a human scale, incredibly gentle and silent. Deep within the molecular hydrogen clouds that wrap around the nebula like a warm blanket, the temperature drops significantly. Here, atoms can link together to form molecules protected from the harsh ultraviolet light by the heads of the cometary knots. These regions are like the shadows beneath a great tree, offering a cool, dark refuge from the blistering heat of the central white dwarf. Scientists use specialized cameras to detect the vibration of these hydrogen molecules, which hum with a frequency that is far too low for the human ear to hear, but which can be seen by our telescopes as a faint infrared glow. Picture the entire Helix Nebula as a giant, glowing clock. The central star is the winding mechanism, and the expanding rings are the hands, marking the passage of centuries. Every 1,000 years, the nebula grows by about 1% of its current size. It is a clock that will only run for a short time, perhaps another 10,000 years before the gas becomes so diffused that the light finally goes out. You are standing in the middle of a fleeting moment of beauty, a temporary masterpiece of physics. Surrender to the feeling of being a small but essential part of this clockwork. The atoms of oxygen you are observing, glowing teal in the dark, are the same type of atoms that now circulate through your own bloodstream. The nitrogen that gives the outer rim its reddish hue is the same nitrogen that makes up the majority of the air in your lungs. There is no separation between you and the helix. You are simply a different arrangement of the same cosmic ingredients. In the silence of NGC 7293, the boundaries of the self begin to soften, merging with the slow, predictable expansion of the gas and the steady, ancient light of the white dwarf. Everything is exactly where it should be, moving according to laws that haven't changed in billions of years. You are drifting in a sea of absolute certainty, a weightless observer in the grand, quiet theatre of the stars. Observe the way your presence here feels entirely natural, as if you are returning to a home you have never visited, but have always known. This weightless suspension in the Helix Nebula is a mirror for your own existence. Every atom within you that is heavier than hydrogen, the carbon in your DNA, the oxygen you breathe, the nitrogen in your muscles was forged in the nuclear furnace of a star, much like the one that created this shimmering cathedral. Scientists have determined that the Helix Nebula, catalogued as NGC 7293, is the closest planetary nebula to our home world, sitting at a distance of approximately 650 to 700 light-years. This proximity makes it a unique laboratory for understanding our own origins. When you look at the glowing teal center of the nebula, you are looking at your own chemical inheritance. At this very moment, notice how the central star, the white dwarf WD 2000, 226 to 210, continues its slow, silent cooling. Though its surface temperature is a blistering 120,000 Kelvin, it is no longer undergoing nuclear fusion. It is a cooling ember, a crystalline sphere of carbon and oxygen that has spent its lifetime savings of energy. Imagine this star as a great, silent grandmother of the cosmos, having breathed out her outer layers to provide the raw materials for future worlds. The 0.3 solar masses of gas currently expanding around you, equivalent to about 100,000 times the mass of the Earth, is a gift to the future. Eventually, this gas will mix with the cold molecular clouds of the Milky Way, potentially collapsing under gravity to form new solar systems. The atoms that make up your body today might once have been part of a nebula exactly like this one, billions of years ago. Picture this. The expansion you are witnessing, moving at 31 kilometers per second, is a process of incredible patience. In the time it takes for you to take one slow, deep breath, the edge of the nebula has moved about 150 miles further into the void. This pace is slow enough that, from our perspective on Earth, the nebula has barely changed since Carl Ludwig Harding first spotted it in 1824. Yet, on a cosmic timescale, the planetary nebula phase is incredibly brief, lasting only about 10,000 to 15,000 years. We are living in a rare window of time where the light from the central star is still strong enough to make the gas fluoresce. It is as if we have walked into a garden just as the most beautiful flower has opened its petals, a bloom that will last only a few days in the context of a century. What's happening now is a profound connection between the micro and the macro. Deep within the cometary knots, those 20,000 glowing filaments we've observed, scientists using the Hubble Space Telescope have discovered that the gas is surprisingly dense. Each knot's head is about 10 billion miles across, or roughly 100 times the distance between the Earth and the Sunday. Within these knots, the atoms are shielded from the harsh ultraviolet radiation of the central star, allowing them to remain cool and molecular. This is a cosmic nursery within a graveyard. These knots are the seeds of the nebula, chunks of material that are resistant to the stellar wind. They remind us that even in the midst of a star's death, there are pockets of stability and protection. Consider the longevity of the light you are perceiving. The photons hitting your eyes were emitted from the nebula in the late 1300s. While humans on Earth were navigating the complexities of the 14th century, these particles of light were beginning their journey through the absolute zero of the vacuum. They have traveled 4 quadrillion miles to reach you. This distance is so vast that it helps put our own daily concerns into a healthy, quiet perspective. In the grand geometry of the helix, which spans nearly 3 light-years across, the small fluctuations of a single human life are absorbed into a much larger, more enduring rhythm. Notice how the colors of the nebula, the 500.7 nanometer teal of ionized oxygen and the 656.3 nanometer red of hydrogen, act as a biological map. In 2005, the Spitzer Space Telescope's infrared eyes revealed a dusty disk in the very center of the helix, likely caused by collisions between comets that were once part of the star's original planetary system. This discovery tells us that the star, WD 2000, 226 to 210, likely had a family of planets and comets, much like our own solar system. As you drift, permit yourself to feel the kinship between our world and this one. Our sun, in about 5 billion years, will follow this exact same path. It will expand into a red giant, engulfing the inner planets, and eventually shed its layers to create a stunning nebula of its own. To look at the helix is to see the distant future of our own home, not as a tragedy, but as a majestic transformation. Scientists discovered that the main ring of the helix isn't a simple circle, but a complex arrangement of 2 nearly perpendicular disks. This suggests that the star might have had a companion, a second star that helped shape the outflowing gas into the eye we see today. This possibility of a binary system adds a layer of social complexity to the cosmos. Even stars often work in pairs, influencing each other's lives and legacies. At this very moment, you are moving through the intersection of these 2 disks, a place where the gas densities are slightly higher and the light scatters in intricate, lace-like patterns. Invite a sense of peace to wash over you as you consider the density of the white dwarf. A single cubic centimeter of its material has a mass of about 1,000 kilograms. This density is the result of gravity winning a long, slow battle against the star's internal pressure. Now, however, the battle is over. The star has reached a state of degenerate equilibrium, a physical stability that will last for trillions of years. It is no longer struggling, it is simply existing. You can mirror this state in your own body, allowing your muscles to find their own version of equilibrium, letting go of the nuclear fusion of your daily efforts and settling into a quiet, dense, and comfortable stillness. Deep within the nebula's structure, the radial velocity, the speed at which it moves toward or away from us, has been measured at roughly 27 kilometers per second. This tells us that the entire system is part of a grand, choreographed drift through the Orion arm of our galaxy. Nothing is truly stationary. Everything is part of a slow-motion river of stars and gas. The helix is located in the Aquarius constellation at a right ascension of 22 hours and 29 minutes and a declination of -20 degrees. Even though it seems isolated, it is part of a galactic community bound by the same gravitational laws that keep our moon in orbit and our feet on the ground. Notice the tadpole tails of the cometary knots once more. These tails stretch for 1,000 astronomical units, 1 AU, being the distance from the Earth to the Sunday. They represent a struggle between the star's fast wind, moving at 1,000 kilometers per second, and the slower moving gas of the nebula. This interaction creates the beautiful, streamlined shapes we see. It's an analogy for our own lives. The wind of external events shapes us, but our heads, our core selves, remain dense and resilient. You are like one of these knots, a solid, enduring presence, even in a vast and changing environment. The Helix Nebula is a low excitation nebula, meaning the central star isn't quite hot enough to ionize helium, but it is perfect for lighting up oxygen and nitrogen. This creates a softer, more subtle glow than you might find in more violent regions like the Orion Nebula. This softness is conducive to your rest. It is an environment of just enough, energy enough, to create beauty, but not so much as to be chaotic. In the silence of NGC 7293, the vacuum is so thin that if you were to gather all the gas in a column 1 mile wide stretching from the star to the edge of the nebula, it would weigh less than a single gallon of water. What's happening now is the realization that you are not merely an observer of the universe, but a participant in its long-term cycle of renewal. In the year 2003, a team of astronomers used the Mosaic 2 camera on the 4-meter Blanco telescope in Chile to create one of the most detailed images of the helix ever made. They found that the nebula's outer halo extends even further than previously thought, merging almost imperceptibly with the interstellar void. This suggests that there is no sharp boundary where the nebula ends and the rest of the universe begins. Everything is connected. As you continue to drift, weightless and free, allow this connection to soothe you. You are made of the same materials, governed by the same laws, and part of the same history as the helix. The 10,600-year-old expansion of this nebula is a slow heartbeat in the life of the galaxy, and your own breath is a part of that rhythm. There is no need for hurry, no need for effort. You are a piece of stardust resting in the heart of a cosmic eye, surrounded by 700 light-years of protective silence. The universe is ancient, stable, and profoundly beautiful, and at this moment, you are simply one of its many ways of knowing itself. Everything is in equilibrium, everything is at rest. At this very moment, we are transitioning into the most intimate layers of the Helix Nebula, moving from the broad strokes of its geometry into the fine, granular details of its sensory environment. Imagine the silence here not as an absence, but as a presence, a dense, velvety quiet that wraps around you. While space is a vacuum, if we were to translate the radio emissions of the nebula into the range of human hearing, you would hear a low, rhythmic thrum. This is the sound of ionized gas molecules vibrating in response to the intense ultraviolet light of the central star. Scientists have mapped these emissions using the Very Large Array, and they reveal a structured, nearly musical regularity to the way the gas expands. Notice how the colors around you are not merely visual, but indicators of chemical activity. The teal-blue glow you see in the pupil of the eye is the specific signature of doubly ionized oxygen, emitting light at a wavelength of exactly 500.7 nanometers. Picture this. The atoms are being struck by high-energy photons from the white dwarf star WD 2000, 226 to 210, knocking electrons out of their orbits. When these electrons eventually return, they release that precise teal light. This process, called fluorescence, is the same physics that powers a neon sign or a fluorescent light bulb on Earth. As you drift through this green-blue fog, you are moving through a sea of energized oxygen, the very element that sustains life, here transformed into a glowing, ethereal mist. At this very moment, the temperature gradient is a study in extreme physics. Close to the central star, the environment is blistering, with the stellar surface reaching 120,000 Kelvin. Yet, as you move toward the outer rings, the gas cools significantly to about 10,000 Kelvin. While that sounds incredibly hot, the gas is so thin, with a density of only about 100 to 1,000 atoms per cubic centimeter, that it would feel like nothing against your skin. It is a heat of motion, not of contact. To understand this, imagine the difference between a hot oven and a single spark from a campfire. The spark is hot, but its mass is so small it cannot transfer that heat to you. This is the comforting void, in its most literal sense, a place where the energy is immense, but the touch is as light as a shadow. Deep within the inner rim, you might notice a subtle metallic scent if your senses could pierce the vacuum. Astronauts often describe the smell of ionized space as similar to ozone, hot metal, or even seared steak. In the Helix Nebula, this would be the scent of the interstellar medium being cooked by the star's radiation. Scientists discovered that the nebula contains complex molecules, including polycyclic aromatic hydrocarbons, which are carbon-based molecules that, on Earth, are found in soot and charcoal. You are drifting through a cosmic workshop where the basic building blocks of organic chemistry are being scattered into the dark. Notice how the texture of the nebula changes as we approach the cometary knots. In the year 1996, the Hubble Space Telescope's Wide-Field Planetary Camera 2 provided the first high-resolution look at these tadpoles. There are at least 20,000 of them, and each one has a head that is approximately 1.2 billion kilometers in diameter. That is about 8 times the distance from the Earth to the Sunday. These knots are not soft. They are dense, cold clumps of neutral molecular gas and dust. They have a mass roughly equivalent to the entire planet Earth. As you glide past them, they feel like solid islands in a sea of light. The tails of these knots stretch out for 100 astronomical units, nearly 9.3 billion miles, streaming away from the central star like the wake of a ship. What's happening now is a phenomenon called photoevaporation. The intense light from the white dwarf is literally boiling the outer layers of these knots away, creating those long, trailing tails. This is why they look like comets. Scientists have used the VISTA telescope, the Visible and Infrared Survey Telescope for astronomy, to look through the dust of these knots, revealing the cold molecular hydrogen hidden inside. This hydrogen is the rawest material in the universe, the same gas that collapsed to form the very first stars nearly 13 billion years ago. It is ancient, heavy, and profound. Consider the rhythmic rotation of the system. While the nebula itself is expanding outward at 31 to 40 kilometers per second, the central star, WD 2000, 226 to 210, is also rotating. Measurements of similar white dwarfs suggest they can rotate once every few days or even hours. This rotation helps generate a magnetic field. In 2005, observations of polarized light from the helix suggested that the nebula's magnetic field lines are aligned with its expansion, acting like a set of invisible tracks guiding the gas as it flies into the void. This provides a sense of order and direction to the drift. The gas isn't just exploding, it is flowing with purpose. Picture this. The helix is a low-excitation planetary nebula. This means the central star is hot, but not quite hot enough to ionize helium into its highest states. This keeps the colors of the nebula in the range of teal and red, avoiding the harsher violets and magentas seen in more energetic systems. This low excitation state creates a visual atmosphere that is inherently calming, dominated by the 656.3 nanometer H-alpha red of hydrogen. This red gas forms the outer lids of the cosmic eye. It is the color of a sunset on a humid evening, a deep, resonant ruby that signifies the cooling and settling of the star's discarded layers. Scientists discovered using the GALEX satellite, the Galaxy Evolution Explorer, that the helix has an even larger outer shell of ultraviolet emission that was previously invisible. This shell represents an even older exhalation from the star, from perhaps 20,000 years ago. It shows that the death of a star is not a single event, but a series of slow, rhythmic pulses, like a giant celestial heart beating for the last few times. Each pulse sends a new wave of gas into the surroundings. You are currently floating between the most recent wave and the one that came before it, in a calm lagoon of space where the densities are at their lowest. At this very moment, give your attention to the dust grains. These are not the dust of your home, but microscopic flakes of silicates and graphite, much smaller than a grain of sand. The Spitzer Space Telescope's infrared sensors detected these grains at the 2.4 micron wavelength, clustered in a disk around the central star. This dust is likely the result of a cometary graveyard. Billions of comets that once orbited the star were jostled by its expansion and began colliding, grinding each other down into a fine powder. As you drift, this dust catches the ultraviolet light, scattering it in all directions. It creates a soft, hazy glow that fills the center of the nebula, like the light of a lamp filtered through a silk curtain. Notice how the expansion velocity of 40 kilometers per second is consistent across the entire main ring. This uniformity is a testament to the laws of thermodynamics. The gas expands into the vacuum because the pressure inside the nebula is higher than the pressure of the surrounding interstellar medium. It is a slow, inevitable evening out of scales. Eventually, in about 10,000 more years, the gas will be so spread out that the density will drop to nearly zero and the nebula will vanish from view. The helix is a temporary monument, a masterpiece of physics that exists for only a blink of an eye in galactic history. Scientists have calculated the mass of the gas in the helix to be 0.3 solar masses, which is about 600 octillion kilograms of material. This massive amount of gas is currently occupying a volume of about 15 cubic light years. This means that for every cubic mile of space, there is only a tiny fraction of a milligram of matter. This extreme dilution is why the nebula is so transparent. You can look right through it to see galaxies millions of light years away. It is a structure of immense size but almost no weight, a ghost made of light and law. Deep within the structure, the radial velocity of the system, its movement toward our solar system, is measured at roughly 27 kilometers per second. This means that while you feel stationary, you are actually part of a massive 650 light-year-long journey through the Aquarius constellation. The nebula is a traveler, just as you are. It is moving through the interstellar medium, interacting with the sparse gas and dust of the galaxy, creating a bow shock where it pushes against the background. As you observe the interplay of the OII teal and the H-alpha red, allow yourself to recognize the beauty of this chemistry. The 500.7 nanometer light and the 656.3 nanometer light are not just colors, they are the universe's way of telling its story. They are the fingerprints of elements created in the hearts of stars. You are a part of this chemical narrative. The iron in your blood, the calcium in your bones, it all has a spectroscopic signature, just like the helix. In this weightless, silent gallery, the distinction between human and cosmos begins to dissolve. You are a localized collection of the same atoms that make up this 8 light-year wide eye. The white dwarf star at the center, WD 2000, 226 to 210, is your anchor. It is small, dense, and incredibly stable. It has finished its work and is now simply resting, radiating its remaining warmth into the dark. You can mirror this transition. Your work for the day is finished. Like the white dwarf, you are now in a state of quiet radiation, letting go of the heat of the day and settling into the calm, predictable rhythm of the night. The Helix Nebula, with its 20,000 knots and its 10,000-year history, is your witness. It is a place of profound peace, where the laws of physics create a sanctuary of light and silence. Everything is moving exactly as it should, at 40 kilometers per second, toward a state of total, beautiful equilibrium. As our journey through the Helix Nebula reaches its gentle conclusion, we find ourselves hovering at the very threshold of the comforting void. At this very moment, the light from NGC 7293 is performing its final, slow-motion dance before your eyes. To understand what is happening now, consider the step-by-step process of this star's quiet transition. It began nearly 10,000 years ago when the central star, now the white dwarf WD 2000, 226 to 210, exhausted the hydrogen fuel in its core. As the internal nuclear pressure failed, the star did not vanish. Instead, it began a rhythmic expansion, swelling into a red giant. Gradually, over thousands of years, it exhaled its outer layers in a series of thermal pulses. What you see now, this magnificent eye in the constellation of Aquarius, is the result of that patient, sequential shedding. Notice how the expansion has reached a state of predictable, cooling grace. Scientists have measured the current expansion rate at approximately 31 kilometers per second. This means that every hour, the nebula grows by over 111,000 kilometers. Yet because it spans nearly 3 light-years across, this growth is invisible to the casual observer. It is a process of unfolding that requires no effort, much like the way your own body settles into sleep. The 0.3 solar masses of gas that make up the nebula are currently drifting into the interstellar medium, a process that will continue until the gas becomes so diffused it simply merges with the background of the Milky Way. Consider the central white dwarf one last time. It has a mass of roughly 0.57 times that of our Sun, but it has been compressed into a sphere only slightly larger than the Earth. Because it is no longer generating new energy through fusion, it is cooling by the process of simple radiation. Currently, it sits at 120,000 Kelvin, but over the next several billion years, it will follow a specific cooling curve. It will transition from a brilliant blue-white to a soft yellow, then to a deep red, eventually becoming a black dwarf, a cold, dark diamond in the sky. This is a process of ultimate stability. The star has finished its work, and it is now entering a period of rest that will last longer than the current age of the universe. Deep within the inner ring, the 20,000 cometary knots are also undergoing a gradual change. Each knot, with its 1,000 AU long tail, is being slowly eroded by the ultraviolet wind. Picture this, step by step. The high-energy photons strip away the outermost atoms of these knots, a process called photoevaporation. This isn't a violent stripping, but a gentle thinning, like a block of ice, slowly turning to mist under a distant sun. The hydrogen molecules inside, which were detected by the VISTA telescope using infrared sensors, remain protected for now, huddled in the cold shadows of the knots' heads. This shielding allows the complex chemistry of the nebula to persist, keeping the teal O3 light at 500.7 nanometers and the red H-alpha light at 656.3 nanometers vibrant and steady. Notice how the light you are perceiving is 700 years old. Those photons were emitted during the 14th century on Earth and have traveled 4 quadrillion miles through the vacuum to reach you. As you watch the nebula, you are literally looking back in time, seeing a process that has already moved past the stage you are observing. This delay is a comforting reminder that in the cosmos, everything has its own timing, its own pace. There is no need to rush toward the future when the light of the past is so serene. What's happening now is the beginning of your own descent into the internal warmth of sleep. Just as the Helix Nebula is a low excitation environment, your own nervous system is now shifting into a state of low excitation. The radial velocity of the nebula, measured at -27 kilometers per second, indicates it is moving toward our solar system at a steady, unhurried pace. You can feel a similar, steady movement within yourself, a pull toward the gravity of rest. Scientists discovered in 2003, using the Mosaic 2 camera, that the nebula's structure is much larger than the visible eye. There is an outer halo, a faint shroud of gas from an even earlier stage of the star's death. This reminds us that there are layers to our own consciousness, and as you move away from the bright, active center of your thoughts, you are drifting into these softer, more expansive outer layers. You are moving from the specific to the universal. Permit your awareness to settle on the fact that you are made of stardust. This is not a metaphor, but a verifiable chemical reality. The carbon atoms in your cells were forged in the triple alpha process inside a star. The oxygen currently moving through your lungs was created in the CNO cycle of a massive sun. These elements were scattered into space by nebulae, exactly like NGC 7293. You are a localized part of the Helix's story. You are the universe's way of experiencing its own evolution. As the nebula expands at 31 kilometers per second, the atoms within you resonate with that same ancient history. As the visual of the eye of God begins to soften and fade into the velvet blackness, notice the feeling of weightlessness in your own limbs. The apparent magnitude of the nebula is 7.6, a faintness that requires a telescope to see, and now, even that faint glow is dimming. The teal light is receding, the ruby red is darkening. You are left in the comforting void, a place of absolute safety and absolute silence. This void is not empty. It is full of the potential for new stars, just as your sleep is full of the potential for a new day. What's happening now is the final transition. The vastness of the 3 light-year wide nebula is shrinking, focusing down into the warmth of your room, the texture of your sheets, and the rhythm of your breath. The cosmic clockwork of the Aquarius constellation continues its work, but you are no longer required to watch it. The white dwarf WD 2226 to 210 will continue its billion-year cooling without your observation. The 20,000 knots will maintain their 1,000 AU tails in the dark. The physics of the universe are stable, predictable, and ever-present. You can trust them. As you drift into the silence, carry these affirmations of the cosmos with you. My body is as stable as the degenerate matter of a white dwarf. My breath is a rhythmic expansion, as steady as the 31 kilometers per second of the helix. I am made of ancient light and enduring elements. The vacuum of the void is a sanctuary of perfect peace. Like the atoms of the nebula, I am returning to a state of total equilibrium. The gravity of sleep is a gentle, natural force. I am a part of the 13.8 billion-year history of the universe. My rest is a necessary part of the cycle of renewal. I am safe in the vast, silent architecture of the stars. The elements of my being are resting in their natural home. I am weightless, unburdened, and connected to the deep. The light of the past protects my present. The vacuum is quiet, and so am I. I am stardust, and to the stardust I return in sleep. Every cell in my body is in harmony with the laws of physics. My mind is a clear window into the deep space of rest. I am settled. I am still. I am home. The 700 light-year journey is complete. The colors of the helix have dissolved into the perfect black of a peaceful night. The expansion continues, but the observation has ended. You are no longer drifting through the nebula. You have become part of the stillness that holds it. There is nothing left to do, nothing left to see, and nothing left to think. The universe is at rest, and you are at rest with it. Good night.